Okay, so we left off, guys, when we left off last week, we were really finishing the factoring of the simple tries. Now, simple trie factoring is, we did it with this X system, and really it's sort of like putting together a puzzle, and now we're going to continue that conversation today, because basically what we're going to do is make it the same procedure, but we're going to do it with the more complicated trinomials that we have to factor. And these are really in this format. If you look at it, it says ax squared plus bx plus c. What they're trying to tell you is that this time there's a number, a coefficient in front of the x squared, in front of that squared term. In other words, there's going to be a number in front of that variable, a number that you cannot factor out by factoring out the GCF. And that makes it a more complicated form of factoring. But basically, I have chosen to just go over this same method with you, okay? Same method, because I figured you're better off just learning one that will work for any problem. Simply won't. And you'll for say to be able to factor out a 2. If we could factor a 2 out, this became a simple trinomial, no coefficient, and it was so much easier to factor. But it doesn't, because these don't have anything in common. So we're stuck the way they are. So the first thing you do is go ahead and set up your factor pairs and do the sign rules exactly like you did before. So we're going to say, okay, we're going to factor it into a binomial times a binomial. That second operation being positive tells us that we use a plus, or we use the first operation for both, and the first operation is positive, so we're going to go positive for both. And then the next thing we do is we say, okay, the variable up here that's squared, well, let's just go ahead and factor it. We know it has to be x times x, okay? Now listen, leave room in front of it this time, because you may have a number in front of these x values, all right? Now we go ahead and do this. Instead of putting the c term at the top of your X puzzle, what you do is you put a times c. You say a, which is 2, times c, which is 3, and we'll say that's a positive 6. B is still what goes down here. So that's the coefficient in the B term, the middle term. Remember, we got A, B, and C terms. So we got a 7 here, don't we? We go ahead and do the sides just exactly like before, but this time the numerator for our fractions here is going to have the coefficient in front of it, whatever that A coefficient is. In this case, it's a 2, okay? I know it's a little bit different. All that's different really is we multiplied A times C, and we put the coefficient that's in front of the A term in front of our variable when we made our fractions. Now what do? Well, we come over here and we say factors of 6 that when combined will give me 7. Same thing we did before now, okay? Factors of 6, well, the only thing is going to be 1 and 6. Never forget 1 times the number, okay? Because at first it doesn't look like that's possible. So what I do is I say, well, that's a plus 1, positive 6. I'll go over here and say a positive 1, a positive 6. And my first factor, my first binomial is right here, 2x plus 1. I'm going to go ahead and put it in one of those. But this one, pay attention to this part, is a little different too. It reduces. In other words, I've got the 2 and the 6, and I'm going to simplify that. I'm going to divide both of them by 2, and this one becomes x over a positive 3. So what's the second binomial? Well, here it is, x plus 3. Okay? So it just reduces. That's what having that 2 up there does for you. Okay? So that's why you have to have it. Now look, we must check these, and you really have to FOIL these to check. You're going to say first terms, 2x plus times x is 2x squared. And then you're going to say last terms, 1 times 3 is 3. That's so easy that I don't even write it down. Then I do inside, I get 1x. And I do outside, I get 2x times 3, which is going to give me 6x. When I combine those, I have 7x, and that's what I have in the center. Any questions so far? Okay? This is a good system. If you're not familiar with factoring, if you need a system, this is a good system because it works for both of them, both types of trinomial problems, okay? Let's take a look at this next one. First thing we do, look for a GCF. Anybody see a GCF in that one? No? Okay, so we're stuck. Let's set up our binomial factors, our binomial pairs. We look at the second operation, it's a plus. It tells us to use the first one for both. So I'm going to have two negatives here, right? I'm going to factor that x squared, leaving room in front of it because this time there might be a number. I'm going to come over here and I'm going to say a times c, and I'm going to get 24. Then I'm going to put down, what do they have to equal? Negative 14. Okay? Now, let's do the sides. We're going to have 3x as the numerator for each. We're going to come over and factor 24. We need factors of 24 that will combine to give us a negative 14. Now listen, both of these factors have to be negative. Why? Well, I know that because look at my signs. But I also know that the only way I'm going to get a negative is to have a negative times a negative be a positive. And when I add them together, of course, I add two negatives and I'm going to have a negative, right? That's the only way this will work. So what factors of 24 do you see that can combine to give me a negative 14? Negative 2, negative 12. Now, if you didn't see it, you'd start by saying 1 times 24, right? Negative 1 times negative. And then you work your way up. 1 times something, 2 times something, 3 times, until you found it, okay? Or not. If you don't find it, the thing's prime. But now I've got a negative 2, a negative 12, and my only thing now is, do I reduce these? Will they reduce? Well, this one will not. 3x minus 2 is my first binomial. My second one, that'll reduce. I'll divide them both by 3. So what do I have? I have 1x over a negative 4. So my second binomial is x minus 4. Okay, check it. 3x times x is 3x squared. Negative 2 times negative 4 is positive 8. We're good so far, right? Let's do inside. Negative 2 times x, negative 2x. Outside, 3x times negative 4, negative 12x. Negative 14x, and that's what we have in the center. Okay? Are you good? Okay? All right, let's see about this next one. This one is 6x squared minus x minus 12. No GCF, right? This time I've got that interesting possibility here. Look, the second operation is negative. When I set up the signs, if that second operation is negative, I don't even look at the first one. I just pick and do one of each. It doesn't matter if I make it plus minus or minus plus, okay? But one of each. Now let's factor the x squared. And let's say 6 times negative 12. What is that? 72, negative 72, right? And let's put the b term in there. What do I put down here in the bottom? Negative 1. You see it? There's no number, so it's a 1. It's understood, isn't it? All right, the sides. I'm going to say 6x in both of them. All I'm doing is putting down that first term without the square, right? I took the square root of it. So I'm going to say 6x for both of those. I'm going to say factors of negative 72 that combine to give me a negative 1. Well, one's going to have to be positive and one's going to have to be negative for this to happen, right? So I'm going to have a positive and a negative. What do you see? If you didn't see it, you'd say 1 times 72, well, that don't work. 2 times 36, well, that won't work. You go 3 times and you keep working your way. But do you know factors of 72 what? 8 and negative 9. I know I need factors that are next to each other. If it has to equal a 1 or a negative 1, those factors have to be right next to each other, right? Which one's negative? Well, my answer has to be negative, so the bigger one has to be negative. So if I combine 8 and negative 9, I'll get a negative 1. You good with that? So here's how I'm going to put them. 8 negative 9. It doesn't matter which one I use. The only thing that matters is I have to reduce these. Both of these numbers will divide by what? Yeah, they'll divide by 2. So I'll say 6x divided by 2, and I'll say 8 divided by 2. That's good, right? Can I reduce this fraction? Divide by what? 3. 6x divided by 3, and negative 9 divided by 3. Okay? Those are my binomials. Now this one has to go wherever I had the plus set up. 3x plus 4 is going to be here. And the other one is negative. It's the 2x minus 3. That's the only thing that I do have to place them wherever I put the negative and positive over there, right? And now let's check it. 3x times 2x, 6x squared. 4 times negative 3, negative 12. Inside would give me 8x, positive 8x. Outside would give me a negative 9x. When I combine them, I get a negative 1x, which is what I have in the center, negative x, right? Make sure you're good with this before I go to the next one, okay? Any questions? Yeah. Mm-hmm. Okay. All right. Next one. Let's take a look at this one because it's changing things a little bit on us. The first thing you need to notice about it is that a term is negative. Now listen, we never start factoring with a negative, first term negative. We have to factor out the negative. That's required, okay? But the second thing you should notice about this problem is these are all even numbers, aren't they? I know they have a GCF of at least 2, don't I? So I'm going to look for a GCF. I know I have to factor out a negative something, but it's going to be a negative 2 or bigger. Is 2 as high as I can go, or does anybody see anything else that will factor out of all 3 of those numbers? What do you think? 2 is it, isn't it? I kind of think so too. Let's try it. And then if we don't like it, we can always change our mind, okay? So we're going to say negative 2. And look, I'm factoring it out as a GCF, so I'm leaving this. But when I factor out a negative, it changes the sign of everything in parentheses. This one became positive. These other 2 became negative. Go ahead and put your signs down because you know what it is. You don't get confused, okay? All right, so I'm factoring out a 2. 2 times what to get back to 12x squared? Well, 6x squared, right? Look and check it. Negative 2 times 6x squared gives me a negative 12x squared. You could say division if you wanted. I could say 22 divided by negative 2 gives me a negative 11x, right? I could say 4 divided by negative 2 gives me a negative 2. Or I can look at it the other way. I can say what multiplied times negative 2 would I use to get back to a 4, okay? Whatever helps you to do that. And then I look at my trinomial again. Did I get all of the GCF? If not, I'm going to start it over and do a bigger number. But it looks like there's nothing they have in common now, so 2 is it. Now, let's leave our negative 2 out there and put down our factor pairs. What signs do I need? What operations do I need in these? Say it louder, somebody. Yeah, one of each one. Doesn't matter where I put them. And now let's factor that x squared, okay? Okay, now let's look at it. Don't forget, this is the one you're factoring, not this first one, okay? We already had to pull out the GCF. So this is our problem now. So 6x, or 6 times negative 2, is the top of my diamond. The b term is the bottom of my diamond. Don't forget the signs, okay? The sides, I'm going to put 6x in the top of each of them. And then I'm going to come over here and factor negative 12. I need factors of negative 12 that will combine to give me a negative 11. What did you find? What do you think it is? Yeah. Yeah, negative 12, positive 1. That's going to be it. Negative 12, positive 1. Now, one of these factors is going to reduce, isn't it? This one looks like I can divide them both by 6. So I'm going to say x over a negative 2. That's going to be my first one. Well, it's got to be the negative one, x minus 2, right? And over here, I've got 6x over positive 1. Well, I can't do anything with that one. At this point, I'm ready to check it. I say 6x times x would give me my 6x squared. Remember, I'm going back to that, what I factored. Don't go back to the original problem, right? And I'm going to say 1 times negative 2, negative 2. And then I say inside 1x and outside negative 12x. Well, that gives me a negative 11x, and that's the middle, and I'm good. That's as far as you really have to take it. If you need to check your GCF and make sure you did the GCF correctly, do so. Any questions on that? If you have a negative as the first term when you factor, you must factor out the negative, even if it's just factoring out a negative 1, okay? You don't ever start factoring with a negative as the first term. Are you ready to go on? Good? All right, let's do some more. I've got bunches of them for you. Most of these on this page look like we're going to factor out a GCF. Look at that first one and tell me what you see as the GCF. Well, 8 doesn't divide into 36. I know, I wanted to do it too. I wanted that to be 32 so badly, okay, but it's not. So what's your next choice? 4. All right, I'm going to try 4. Do you see anything else, though? X. Don't forget that one, right? Because we are not into factoring first terms that are cubes yet, okay? That's not what we're doing. We're just going to factor out, we're factoring with x squared. So let's factor out the 4x. Go ahead and do it and tell me what you get. Or go ahead and write it down, and I will do mine. Okay, check it. And then I want you to take and do your X puzzle over here. I'm going to call it the X puzzle. I don't know what else to call it. Do the X puzzle. See if you can factor, see what your factors come out to be for this new trinomial that we have. Tell me if you need help. Okay, so I said A times C is 44, B term is 9, 2x in both of the sides. Everybody good so far? And then I said I need factors of 44 that will combine to give me a positive 9. Okay, we all got that far, right? All right, did you find them? Anybody? Did you exhaust all the possibilities? How would we know if we had exhausted all the possibilities? Let me show you, okay? You start by saying, I don't see them. I mean, I'm looking at this 44, and in my mind, I don't see factors that can combine to give me 9. So I start the process of eliminating all the possibilities. I go 1 and 44. Nope, that won't work. I go the next number that will divide into 44, 2. 2 and 22. That won't work. 3, well, it won't, right? 44 won't divide by 3. But 44 will divide by 4. 4 and 11. No way is that going to combine to give me 9. Anything, 5 doesn't work. 6 doesn't work. 7 doesn't work. I'm about tired of trying this, aren't you? Once you get past 7, you're pretty much done. 8, nope. 9, I don't have to go very far, do I, to say, look, I don't have any factors of 44 that are going to combine to give me 9. What does that mean? Well, that particular trinomial right there is prime. So we're done. We factored by pulling out the GCF, and that was as far as we could go. But you have to try all possibilities, and this is how you try all possibilities. Doesn't take you long, especially since you got a calculator in your hand, right? All right, let's look at this next one. 27x squared, 27x, 6. Do you have a GCF? What is it? 3. So let's factor out a 3. I would check it again and make sure those didn't have anything in common. Now let's set up binomial pairs. I'm going to let you do this one. This one's not a trick. This one does factor. Go ahead and do it, okay? If you get that one and want to keep going, keep working your way down the page, feel free, all right? If you get stuck, I'm going to come along behind and help you. There's your solution for number 6. Stop me, ask questions if you don't understand something, okay? If you got that one with no problem, give me a thumbs up real quick so I know where we are, all right? You good? Okay, yes.
So how do you find what numbers to put in the
Top or bottom?
this way.
The top is the A term times the C term, just the numbers. So I say 9 times 2. The bottom is whatever is in front, the coefficient in the B, okay? If you go back over to the previous page, I think you might have gotten in here after we went over that, but if you go back over to the previous page, it is listed for you up here in these notes, okay? So you can see that. Maybe it's this page. Nope, it's this page. Okay? But this is A times C, and this is B. Yes?
In this problem, does it matter the order you put the 3 and the 6?
No, over here you mean?
Yeah.
No.
So I put the 2 first, and then I put the 1
Not at all. Yes, any other questions? Okay, next problem. I'm assuming you probably worked ahead. You've looked for a GCF on this one. Look, I know that I have a GCF on this one of at least x squared, don't I? I mean, I know x squared will factor out. They all have x's. The smallest exponent is a 2. That one will factor out. And then I'm looking for something else. Well, 2 would do it, right? But bigger than 2, I think I can go 3, right? I could I do 4? I'm looking for a bigger number because these are pretty big, and I came up with 6. Is that what you factored out? Do you see the GCF is 6x squared? Yep. All right. If you haven't worked it, work it. That's what you're factoring. Okay, your solution to that one is up here. Okay? You pretty happy with this so far, guys? Okay, the next problem. Look, it's got entirely too many variables. We have got to factor out at least some of these variables, and it looks like I have x squared in each term. So I know part of my GCF is x squared. That'll get rid of all of them. I'll just end up with the y's. I'm good with that. Look at my numbers now, and let's see if I can make it go down any with these numbers, right? What have I got? Well, I've got a 9 and a 12. They have something in common. But then there's a 4. And the thing I have to look at, 12 and 4 have something in common, but what I have to look at is I look at 9 and 4, and they have no common factors, do they? Well, if it's not common to all 3 of these numbers, it cannot be factored out. So I'm stuck with 9y squared plus 12y plus 4. I didn't get to factor out any of the coefficients, but I did get to pull the x squared out, and that simplified it down to where it's factorable for me. So I'm going to say x squared. I'm going to set the signs, and I'm going to factor the variable at the beginning that's squared. If I had a variable at the end that was squared, I would factor it too. I think I have one listed for you next time, okay? All right. Next thing I'm going to do is say 9 times 4 gives me my AC term, right? I'm going to say 12 is the bottom. Everything's positive, so I'm not really worried about signs here. And I'm going to go 9y as both of these numerators. And I want factors of 36 that when combined will give me 12. Somebody tell me what you see. Okay, 6 and 6. That works, right? I mean, that's pretty good. If you hadn't seen it, you would only have to go through 6 factors. You'd go 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6, and you would have found it. It doesn't take long to go down the list and check it, okay? Don't tell me you cannot find it. doing that because you can. Simple, especially since you got a calculator. So I got 6 and 6. And now I simplify. Well, these are identical. They're going to simplify the same way too, aren't they? I'm going to divide both of these by 3. I get 3y over positive 2. Same thing over here. It's not going to change, is it? And what I have is 3y plus 2 for both of them. Well, let's check it. 3y times 3y, 9y squared. 2 times 2, 4. Now, guys, let me just tell you, in the first and last, almost always you'll get those right. What you will mess up is inside and outside if you mess anything up. So be sure you check them. 2 times 3y is 6y. 3y times 2 is another 6y. When I combine, I have 12y, and that's what I need. So I have factored it correctly. But look at this and tell me, do you see another way to write it? The answer. How else could this be written besides x squared times 3y plus 2 times 3y plus 2? What would you do? Yeah, power 2, square it, right? So I got x squared times these. This factor was written twice, right? That's another way to write it. Whoops. Much clearer that way, actually. Okay, now this last one that's on this page is a little quirky. I'm looking for a GCF and I don't see one. I really want to see one because it's got x's and y's, and I would love to factor out one of those, but I don't. But I'm okay because look, this is an x squared. Y squared at the end is also okay for me. This is what I'm going to do differently, okay? I'm going to say set the signs. Well, that positive, that plus there tells me to use the first sign for both of them. And then I'm going to factor the x squared. Here's the different part. I'm going to go to the end of it. I'm also going to factor the y squared, leaving room in front of all of those for numbers, okay? And now I'm really set. And that's the only difference I really had to make. The only change I really had to make, okay? Now let's do the 9 times 4 and negative 12. Nobody's confused about where I'm getting those, are you? You're good with that, right? And now let's set up these fractions. The same thing. We just ignore that y at the end. We're just going to set these to be 9x, a term, right? And now we're factors of 36 that give us, combine to give us a negative 12. What are they? Now they both have to be negative, don't they? It's the only way I'm going to say get a positive 36 and have something negative is they both have to be negative. It has to be a negative times a negative to give me 36. But I knew that already because look over here at the signs. They're both negative, aren't they? Okay, so what am I going to multiply? What factors of 36 are going to combine to give me, negative 12? Negative 6, right? I mean, it was the same thing for 12, wasn't it? This time, they're both negative. Okay, negative 6, reduce them. This time, the only thing different here is these reduced to 3y over a negative 2, right? And my factors are 3, that should have been a, oh wait, that is an x, sorry. And this should have been an x. What am I saying y for? Okay, so 3x minus 2, 3x minus 2, and I want you to write that in exponential notation because these factors are identical. You would write it like that, wouldn't you? Any questions on this page? Okay, now listen, let me tell you this. Factoring is, the rest of this class we are going to factor and factor and factor. And then we're going to start solving things by factoring. So your factoring has to get quick because that's not going to be the whole problem. The problem is going to be, what's the solution? Well, I have to factor it first, okay? So the factoring is going to be part of how do we get to the solution. In other words, the only reason we're doing this is so that we can solve for x. We can't solve for x squared, but we can solve for x. To be able to solve for x, we have to be able to factor these things. Trinomials have to be factored, okay? So a lot of problems that you're going to come up with from now on are going to say factor, and you can't be real slow on factoring. So I need you to practice and practice until you have this down pat. All right, you can do this. I'm giving you a system that will always work. No guessing at whether or not you got the factors right. This one will always work for any of the trinomials, which are considered the hardest things to factor. Now let's talk about patterns. Let's talk about making it quicker. On page 6, we're going to talk about something called a perfect square trinomial. Now, perfect square trinomial has to have 3 terms. It's a trinomial, right? And then the first term and the last term have to be perfect squares. Now, that doesn't mean they can't be something like x to the 4th. An exponent that is evenly divisible by 2 is a perfect square, okay? So the first term and the last term have to be perfect squares. That's given. There can't be a minus sign in front of that first term. In other words, if you got a minus sign out here, you got to factor it out. Right? GCF of -1. That's the first thing you have to do. Can't be a minus sign in front of the last term. So those have to be positive, okay? And then the next thing is you can multiply this one times this one and double it, and you will get the middle term. That's a perfect square trinomial. Let's look at some, and I think it might make a lot of sense. Now listen, memorize your squares if you haven't already. I put a table here for you. Practice them. If you don't know them, you simply will not have time to go typing this into a calculator every time you want to know if it, what the square root of a number is or if it has a perfect square. You really need to know these. It's not hard. You've memorized lots worse in your lifetime, and you know a lot of them already. Let's look and see. First thing always, is there a GCF? Well, that last term being a 1 pretty much eliminates a GCF, okay? The only thing they can have in common then is a 1, and that doesn't help us. So now I'm looking at these and saying, let's set the pairs, the binomial pairs. Well, they both have to have a plus sign in them. And I'm going to factor the x squared. And then I'm going to say, is it a perfect square binomial? When I start to recognize it, I don't have to do too much out here with this factoring, okay? When I recognize a perfect square binomial, there's a really easy way to factor it. I look at this and I say, is that first term a perfect square? Well, it's 49. That's a perfect square. X squared, that's a perfect square, isn't it? Yep, that one I can see. Yep, it is. Is 1 a perfect square? Well, guys, 1's a perfect anything. Perfect cube, perfect fifth, perfect sixth, whatever. It's perfect, right? So 1 will fit anything we say. Okay, so those are both perfect squares. Now, if I take the square root of 49x squared, that's going to be 7x. True? If I take the square root of 1, it's going to be 1. If I multiply those two together and then multiply that times 2, I'm going to get 14x. Look what 14x is. My middle term. It's a perfect square trinomial. That's the way I check it. Take the square root of the first one, take the square root of the last one, multiply those square roots together, and then multiply them times 2. In other words, double them. Multiply them together, double them. If that equals your center term, your B term, you have a perfect square trinomial. How do you factor that? Well, it's really easy. It's always going to be the square root of the first one, square root of the second one. They're going to be identical. That's a good thing. Now, can you do, if you don't see it, can you do this X thing with it? Yeah, it'll always work. I say this would be 49, right? And this is going to be 14. And over here I'm going to say 49x and 49x. And I want factors of 49 that add to give me 14. What are they going to be? Well, 7 and 7. And I reduce. Over here it's the same thing, right? And by that time I go, oh, it was a perfect square trinomial. Okay? I'm just telling you, because if you can recognize it, you can save yourself a lot of time. Let's look at this next one. Is the first term a perfect square? Yep. 9 is a perfect square, x squared is a perfect square. So I'm going to go, okay, what's the square root of that one? The square root of 9 is 3. The square root of x squared is x. Is this last term a perfect square? By the way, I had to already check and see that I didn't have a GCF in these things, okay? What's the square root of that last term? Somebody want to tell me what it is? 2y. Now what if I take those two terms and multiply them together? Whoops, 3x times 2y. And then I double it, right? Well, 3x times 2y is 6xy. Times 2 would give me 12xy. Do I care that it's negative? Nope. That negative works right in with my plans. So I know I have a perfect square trinomial. So how can I factor it? Well, look, because it's like this, I know I'm going to have negative signs for both of them. I knew that. And I'm going to say square root of this first one, square root of the last one. They're both the same. Perfect square trinomial, okay? All right, you look at this third one for me and tell me, and I'm not above sending you one that's not a perfect square trinomial, so look at it and see, is this one? If it is, factor it as a perfect square trinomial. See if you can do this. Are you good? All right, example 4 is for you to make one up on your own, okay? What are you going to do? First term has to be a perfect square. Last term has to be a perfect square. Square roots have to be able to be multiplied together and doubled to make your middle term. Do it. Be sure you put a variable in that first term, okay? Makes it easier. Don't put a variable in the second one. That's just complicating your life. You can. Yeah.
For example 3, how come when you factored the 2 out of the 4, you did 2 times 5 times 2?
Down here,
Yeah.
because you multiply the square roots together and then you double it. Doubling it means multiply times 2, right? See, I did that up here too. Multiplied them together and doubled it. And if you get lost on that, the notes are at the top of the page, okay? Go back over those. How are you doing with that? Anybody happy with your trinomial that's going to be a perfect square trinomial? All right. What I need is this. I need a squared, and I need c squared, right? And I need this to be either plus 2ac or minus 2ac. Either one would work, wouldn't it? I don't care if this sign is positive or negative, but these two, the first terms and that last term, both have to be positive. That's all I'm asking you to do. And then you pick a number for A and you pick a number for C. Okay? That's it. Create your own. So I'm going to pick a number for A. Somebody give me a number for A. What if A is equal to what? Okay, so you said what? 64y squared. So that's my first term is going to be 64y squared. Got it? What about this last term? What did you make it? And did you have pluses in here or minus plus? You put a minus and a plus. Like that? Okay. What is your middle term? Okay, let's see if he's right, okay? Let's say this has to be a perfect square and this has to be a perfect square, right? Now, I'm letting this one go even though there's a GCF in it, okay? You see the GCF? I've got at least it has a GCF, but we're just going to let that slide because you did exactly what I asked you to do, okay? So normally we would factor out the GCF before we did the factoring that we're about to do, but we want this to be a perfect square trinomial exercise, so we'll leave it, okay? So now I've got 64y squared. I'm going to say the square root of 64y squared is going to give me 8y. And I'm going to say the square root of 4 is going to give me 2, right? And when I multiply those two together and double it, I have 16y times 2, which is going to give me 32y. Negative is fine. So what he wrote is perfect. It's a perfect square trinomial. You will never have this particular combination of numbers because your first job is always factor out the GCF, and that would give you a different trinomial, okay? But you'd still have a perfect square trinomial if you factor out the GCF, actually. Okay? So you would factor this one into what? Well, we're going to factor it like this. It's going to be 8y minus 2 squared. Now, you see the GCF now that I've factored that? There's a 2 in there, isn't there? So you would factor it out, and you would still be okay. All right? But good exercise for you to start thinking about what's the process, okay? If you can think through the process of creating one, it helps you to be able to see them in the end. And if you can recognize them, you don't have to go through the X game, okay? All right, any questions on that? Are you okay? All right, let's do one more page. I promise you I saved you the easiest page for last. This one you're going to feel like I'm telling you how to cheat on because it's so easy. And basically what this is how do you recognize a perfect square binomial? Okay, a perfect square binomial. Well, a perfect square binomial is called a difference of squares. I wrote that in there already, but I'm going to write it again. A difference of two squares. Why a difference? Because it has a rule. It has to have a minus sign in the center. It cannot factor it any other way. In other words, look at these problems. Negative in the middle, negative in the middle. The operation that's between the perfect squares has to be negative. It's simply, if it's a perfect square on both ends and a positive sign, a plus in the middle, you can go ahead and write down prime, okay? Unless it's got a GCF, it doesn't have anything else. But this negative in the center, I look at it and I go, first guys, do this for me, GCF or not. I don't see one, do you? So we're going to say square root of the first and square root of the second. But the first thing we do is set the signs. How do we set them? One of each. Okay? It's going to factor into two binomials, one positive, one negative. And then all you have to do is say, what's the square root of that first term? What's the square root of 25? What's the square root of x squared? What's the square root of the second term? We put those in the first positions of both of them, okay? Square root of that second term, what's the square root of 16? 4. Put those in the second positions, and we're done. I mean, don't you feel like I just told you how to cheat? I mean, really? But that's it. That's all you do to factor a perfect square binomial, a difference of two squares. Remember what I said. A sum of two squares will not factor. It's prime, okay? You don't even have to try. I mean, you have to try. You have to look for a GCF. That's the only thing you might have. But that's it. Sum of two squares won't factor. Now look, these are tricky because they might factor again. In other words, once I've factored it into the sum and the difference, that second one might be another difference of two squares. So you have to look at that one that has a negative and say, can I do it again? Let's take one and look at that. Let me see if I can go straight to one, and then I'm going to let you practice. Well, okay, let's go down to the bottom. Let's look at this one. For x to the fourth minus 1. Both of them are perfect squares, aren't they? So I'm going to go ahead. I'm getting really happy about this, and I'm going to go 1 of each sign. Square root of the first term. What is it? X squared. Square root of the second term. And you're finished, except you should notice, like I told you, difference of two squares, once you factor it, you better check that second one, the one that has a minus, and say, is it a difference of two squares again? Is it? That x squared is a perfect square. The 1 is a perfect square. So we're going to have to factor it again. Now this one is prime, right? But this one, I'm going to come down and do the whole thing over again. What's the square root of x? Squared. What's the square root of 1? Now I'm done now, right? Because I can't find a perfect square in a simple x, can I? All right, the rest of this page is yours. These other three problems, you should be able to, and I'm going to tell you up front, there's no GCFs in these. If there were GCFs, we would be required to factor them out first, but in this one, there's no GCFs, okay? So go ahead and factor those three. And one of them is going to factor twice. Okay, the first two, I mean, I don't even know if you need me to explain them, right? One of each sign, square root of the first term, square root of the second term. That's all I've done. And I look at that second one, the minus, and I go, can it factor again? Well, no, it's only got an x. It doesn't have an x squared. It would have to if it was going to be a perfect, another difference of two squares, right? So let's take this number, example 4. It has potential because it has an x to the fourth here of having to be factored twice. And that is the one that I told you was going to factor twice, okay? I don't do anything with the first factor, the first binomial, but I come in here and I go, x squared minus 9 is another difference of two squares. One of each sign, x and 3. 3 is the square root of 9, x is the square root of x squared, and that's its factoring, okay? So it came out to 3 binomials. Now that's a simple one. All right, go back over what you have had today, because the next time I see you, we're going to talk about solving. So this has to be, these last 2 lessons have to be solid before I talk to you about solving these, okay? But go back over the different methods of factoring. We've covered every method of factoring that we're going to cover. So what have we done? Listen to me. I know you're getting ready to go, but listen to me. GCF, first step always, okay? The next thing, look at your problems of grouping. If you have 4 terms, possible grouping problem, okay? Grouping is important. So I got a 4-term polynomial. I'm going to look at grouping. Next thing you look at is your trinomials. You've got a simple one and you've got a complicated one. In other words, the simple one does not have a number in front of the very first squared term. The complicated one does. You can solve them both using that X puzzle. And then start looking at this. Now, I didn't go over cubes because we've taken cubes out of here. If you learned cubes, factoring cubes in high school, you will definitely use it in college algebra when you go forward. You might want to go back and look at it again, but you'll go through it there. And we took it out of this course. But the next thing you need to know is, how do I recognize these, perfect square trinomials? And then how do I recognize a difference, to go to the binomials, a difference of 2 squares, okay? Not a sum of squares, a difference of squares. Because you should have a system in your head for looking at that, figuring them out, and factoring them. The perfect square trinomial, you can use the X puzzle if you need to. If you don't see it, go through it the regular way. It'll factor that way too. First step is always going to be factor out the GCF of anything, okay? That's going to be your most important thing to remember, because otherwise you can factor it and you'll get the answer wrong, because there'll still be a GCF embedded in at least one of your factors, okay? Are you good? You got a lot of practice to do, so do that, and I'll see you back here on Wednesday.